Hi, in this video we will understand the working of Address Resolution Protocol ARP through the IP forwarding experiment available in NetSim's Sample Lab Manual. NetSim's Lab Manual provides over 30 sample experiments across a wide range of technologies available in NetSim. As you can see in the manual, the objective of this experiment is to understand IP forwarding within a LAN and across a router. Nodes in any network have layer 2 MAC addresses in addition to layer 3 IP addresses. In this experiment, we will see how IP forwarding is done when a node wants to send data within a subnet and when the destination node is outside the subnet. Address Resolution Protocol ARP is a telecommunications protocol used for resolution of network layer addresses into link layer addresses, a critical function in multiple access networks. In NetSim, we start by navigating to create a new project by clicking on Simulation, New Internetworks. In our first section, we will understand IP forwarding within a LAN. For that, click and drop devices as shown in this video. Then set the properties to wired node 1. The transmission type is point to point. The destination is wired node 2 and select the traffic as custom. Note down node 1's IP address, which is 192.7.1.2, and node 2's IP address, which is 192.7.1.3. Also note down the node's MAC addresses. The MAC addresses are generated randomly in NetSim based on system time and hence would differ for each scenario and will be different from what you see on this video. Once the properties have been set, click the packet trace button and provide a file name. Select the type as CSV, which is comma separated value, and its location. Also do ensure that all the attributes are checked for a better and detailed description. Next, we click on the Simulate button, which opens a window where we enter simulation time of 10 seconds, experiment name, and then we enable record animation and leave the seeds at their default values. Then we run the simulation. After the simulation is complete, click on the View Packet Animation link on the left hand side and a window opens showing the network along with playback controls of play, pause, simulation time, and a slider to control the animation speed. Users who are new to NetSim can slow down the slider to a comfortable setting so as to understand the transfer of the packets more easily. Now let us study the simulation in detail with the help of the packet animator. It proceeds in the following manner. Node 1 sends the ARP request to switch 4. Switch 4 sends that ARP request to all the other ports except the incoming port. In other words, it sends it to node 2 and router 6. In our experiment, node 2 is the destination of node 1, and so node 2 replies to the ARP request of node 1 and sends the ARP reply to switch 4. Switch 4 forwards the ARP reply to node 1. Let us understand why this is done. Firstly, node 1 only knows the IP address of node 2 and does not know the MAC address of node 2. This MAC address is required to be known to send the data packet. So in this case, node 1 first looks up its ARP table to see if there is any record of a MAC address corresponding to node 2's IP address, which is 192.7.1.3. Since this is not available in the beginning, node 1 sends out a broadcast ARP message requesting the MAC address for 192.7.1.3. Node 2 responds to this with the ARP reply, which contains its own MAC ID. Then node 1 updates its ARP table with node 2's MAC address, while node 2 also updates its ARP table with node 1's MAC address, which it got through the ARP request from node 1. Note here that the router does not forward the ARP packet because the destination IP is within the same LAN. After this process is complete, TCP establishes the connection between the source and destination, and then the source starts to send data to the destination. Next we will see the second sample of IP forwarding across a router. For that, close and reopen the saved experiment. In this experiment, we set similar properties as in the first example, but this time we set node 1's destination as node 3. Note down node 3's IP address, which is 192.7.2.4. Then the same procedure is followed. Ensure that the packet trace is set up and simulate with record animation option. Now go to view animation and play the animation. First, node 1 transmits the ARP request to switch 4. Switch 4 sends the ARP request to all other ports except the incoming port. Note that the destination IP for the ARP request is the router's default gateway, because the destination IP is in another LAN. So router 6 sends the ARP reply to switch 4. Switch 4 forwards the ARP reply to node 1. Next, node 1 sends the TCP SYN packet to switch 4. Switch 4 forwards the TCP SYN packet to router 6. At this moment, the router 6 needs to forward the TCP SYN packet to node 3, but it doesn't have the MAC address of node 3. So router 6 sends the ARP request packet to switch 5. Switch 5 forwards the ARP request to node 3. Now node 3 sends the ARP reply to switch 5, and switch 5 forwards it to router 6. After getting the ARP reply, the router sends the TCP SYN packet to establish the connection. After TCP's three-way handshake is complete, data transmission starts from node 1 to node 3. The same flow of packet transmissions can also be seen in the packet trace file. Hope you enjoyed this video on the working of ARP in NetSim. Thank you.